The figure shows the amount of water in two rectangular containers, X and Y at first. So you can see there is water in both the containers, but they are not filled to the brim. Rain is going to pour 1/5 of the water from X into Y to fill it to the top without overflowing. So I have divided the amount of water in X into 5 equal parts. When 1/5 of the water from X, which is the red shaded part, is poured into container Y, it will fill up container Y to the top without overflowing. That means the red shaded part in X is the same amount or has the same volume as the red shaded part in Y. So with this understanding, we are able to find out part A of the question, how much water was there in X at first. So we're going to make use of the red shaded part in container Y to find out what's 1/5 of the water in X. All we have to do is just to take the length of this container Y, and that's 15, multiply with its breadth, and that's 12 centimeters, and multiply that with the height of the water here, and that's 8 centimeters. So let me write that down first. And we will get 1,440 cubic centimeters. So this is where the 1,440 cubic centimeters of water is. And since it was poured from X, the red shaded part in X is also 1,440 cubic centimeters. So now we are able to find the volume of water in X by taking 5 times 1,440. So there's 7,200 cubic centimeters of water in X at first. Moving on to part B, we then pour all the water from Y into X. Maybe you can think of it this way. You can pour back the 1,440 cubic centimeters of water from Y back into X first. That way, we will get back the same original amount of water in both X and Y. So if I were to do that, this is what will happen. Ray is going to pour this 1,440 cubic centimeters of water from Y back into X. And we will get back this original volume of water in both X and Y. If you were to continue pouring the remaining water from Y into X, there will be 120 cubic centimeters of water that will overflow from X. So is there a way that we can prevent the water from overflowing in X? Apparently, yes. All we have to do is to don't pour the 120 cubic centimeters of water from Y to X. That way, no water will overflow. Suppose the blue shaded part represents 120 cubic centimeters of water. We are not going to pour this blue shaded part, the 120 cubic centimeters of water, into X, so that no water will overflow. So if I were just to pour the amount of water that I've shaded in green from Y to X, it will fill up container X to the brim. So that means to say that the green shaded part in Y has the same volume as this green shaded part that I'm going to shade in X. I repeat, the amount of water that I have shaded in green in container Y has the same volume or is the same amount as the green shaded part in X. Because if I don't pour the 120 cubic centimeters of water from Y into X, then no water will overflow. So if you are aware of this, you can find the volume of the green shaded part by using container Y. But we need to find the volume of the green shaded part and the blue shaded part first by taking 15 times 12 times 14. And we're going to take away 120 cubic centimeters of water from that answer to find out how much is the green shaded part. So with this equation, we found that the green shaded part is 2,400 cubic centimeters. So here's where the 2,400 cubic centimeters is. And based on the answer in part A, we know that there was 7,200 cubic centimeters of water in container X at first. Now, we can find the total capacity of container X now, and that is to find the sum of 2,400 and 7,200. That will give us 9,600 cubic centimeters. And because they want to find the height of container X, take note that we are not finding the height of the water in container X. We are finding the height of container X. So we're going to take the capacity of container X, and that's 9,600, divide by its base area. And the base area can be found by taking 20 times 15. So let me write that down in an equation. So the height of container X is 32 centimeters. Now, many a times when students are stuck in part B, and that's usually the case because part B of the question is usually more challenging, my advice is to make use of the question in part A, or maybe even the answer in part A, to help us solve part B. Because most of the time, there's a reason why they ask you part A first before part B. So learn to ask yourself, why are they asking me this question in part A? When you ask yourself this question, maybe you're able to see something that you can't see earlier on. So hopefully this helps you to understand this question better.